Hey, hi everyone. I hope everyone is doing well. So, today we are going to learn about an important concept in system design and it's related to caches. Caches are important from the perspective when you're designing databases. Very frequent writes or reads to the databases by applications might not be suitable. So uh, you basically insert caches in between to actually allow for performance improvement, right? So remember that I think in all the system design concepts, or if you're introducing a new system design component, there's always going to be a trade-off between performance and cost. So if I were to give you, let's say, infinite uh, resources, which could be infinite budget, then you could design probably the best performance systems. But if I restrict your cost, then there will be trade-offs, right? So caches are basically used when there are a lot of reads from uh, your, let's say, database, right? You could have your postgre database, you could have your sql database, any sort of databases, and your application layer, for example, a user form, or just your mobile application. There are a lot of frequent reads from database, which is definitely not the most ideal way of designing any application. So uh, you need to have your user response to be fast. So imagine if you have a million records, and every time you have your users actually requesting their details that they might have shared earlier. Those details are stored in the database, but when you try to retrieve those from the database, it is going to be a problem, right? Because the database query that you write would basically fetch all the records and then only result in the most relevant records, right? So instead, what you do is you basically use cache. So some of the examples could be, for example, search queries. Google does it, like in the search bar. The items that you have already searched for reappear very quickly. That's because there's a cache running just behind your front end application layer. Price updates of items on e-commerce site. So again, you might be looking and browsing to the e-commerce site, and today you might find one price for some items, tomorrow you might find different prices, right? So how are those prices updated that frequently, right? So you don't, every time the price updates happen, you don't go and retrieve the data from the database, update it in the database, and then retrieve it back, right? So caches basically will improve the performance of use cases like these. um, how are caches designed? Caches are usually a piece of, like, a hardware or a software on the storage layer. You can keep the most recent copy of the data. Now, what is most recent? Fairly subjective, but uh, I hope you get the gist of what are caches, why are caches used, and how are caches actually. Uh, Now we get to some terminology related to caches. So I think uh, every time there is a request, right, coming from the application layer, uh, you will either find the data or you will not find the data. When you find the data in the cache, it's called a cache hit, and if the data is not present in the cache, then it's called a cache miss. Now, why is the data not present? It could be because of the reason the data is stale. You had, let's say, 100 records in the DB. You chose to keep only the 10 records, right? The last record out of the 10th record could be the stale record, or the last two records could be stale, right? So what do you do then? You basically remove the stale data, or you evict the stale data, correct? So and for caches, basically there are a lot of eviction policies that you can use. Essentially, these policies help you to keep the most fresh copy of the data, if I have to put it that way. uh, you can use the least recently used eviction policy, which means that an item in the cache that has been most recently used will always be kept. So you can rank order, for example, your items in the cache, and the one that has the lowest rank, you basically kick that item out, right? Or set of items out. Least frequently, basically, uh, that you can design by looking at the number of times the item has been hit, right? Again, a rank order on frequency. You keep the most recent hit items, and you kick out the items that are not frequently used on the lower ranks, right? LIFO and FIFO fairly like straightforward. Last in, first out, first in, first out. So imagine like designing the cache, the first user query basically goes at the last, right? So that means if you were to use FIFO, then that item on the cache will be kicked out first. Last in, first out would be the most recent item on the cache will be the first out item, right? So these are like I think some commonly used eviction policy. I think LRU and LFU are the ones that I've seen in like real life use cases when, for example, form queries are being like sent by the users on the front end, let's say form filling application layer, and then what happens is that you basically let's say are trying to retrieve some part of the form information that you have the user has already filled in, right? So uh, you would have let's say 100 such users in your database. uh, you would know that who are the users that are least frequently visiting the website, right? So for those users, you don't keep the data in the cache. You only keep for maybe like the 10 most or the 20 most or whatever it is, right? The frequently used user information from your form service in the cache. Um, I think cache invalidation again, this is primarily I would say consists to maintain consistency across the DB and the application layer. uh, so what happens usually is that if there are writes that are happening on DB, you want the reads to be also consistent, right? Uh, and your end, let's say layer could be the application layer, or it could be a user layer, or it could be a client layer, right? I mean, you want the behavior to be consistent. What it means is that whatever is present in the database should be reflected back to the application or the users or the client layer, right? So invalidation basically helps to keep the cache and the DB behavior consistent. If that is not the case, then the problem is that whatever you have in your database is not going to be reflected in the cache, which means when the cache is being hit through an application request, you are not going to get what is actually present in the database, right? So you absolutely want to have this consistency, and for that there are like some invalidation techniques, cache invalidation techniques that you can utilize. So the first one, I think, as the name suggests, is the write through cache. What happens in this is that any change that is coming through your application layer is first written onto the cache, and then only it proceeds to writing in the database. So the advantage of this is that your application layer, for example, might be doing a lot of reads, right? So if it is doing a lot of reads, then any change that is happening through writes, if it is put in the cache first, then those reads are going to be very consistent because those reads are basically getting the most, let's say, recent updates from the cache, right? And then because database is also updated, but after the cache is updated, your database is also consistent with what the cache has, right? Another type of invalidation method is the write back cache. Haven't seen this basically being used a lot. Also, I would say that it's a risky strategy, and the only reason that it is a risky strategy is because it does not write to the database. So what happens is usually from the application, if there are writes, then you basically put those writes in the cache, and then you send some sort of an alert back to the application that the write has actually been successful, right? Now, the problem with this is that your database is not being updated because you're not writing into the database. And when you're not writing into the database, cache, because of its limitation in size, if there is a read request that is not present in the cache, then because the DB has not been written into, you are going to get an inconsistent behavior, right? So a lot of the times, I think uh, you would come across these situations where there are a lot of writes happening from the application layer, uh, and the alerts are being sent. Um, and because you want to have the consistency, what you can probably do is wait for some time and then write to the DB. It is a risky strategy because you're allowing a gap between the cache and the DB writes. It's not happening simultaneously, which means you are not going to be 100%. I would say in sync with what is present in cache and what is present in DB of the same data copy or the same set of data copy, right? And then I think cache aside, uh, again, fairly, I would say, fairly used policy, invalidation policy. So what happens in this is that if there is a request from the application layer and if the data is found, then it is uh, pushed back or retrieved back from the cache back to the application. If the data is not found in the cache, then let's say if the data is not found in the cache, then basically it goes to the DB. And if the data is found in the DB, then it goes back and updates the cache, and then it retrieves that information back to the application. So these are some of the I would say policies, sorry, invalidation, cache invalidation techniques. um, I think in part two, so this has been like, just an introduction. Feel free to drop in comments uh, about any of the concepts that you haven't understood. But I think in part two, what I would probably cover is information related to the design of cache on, let's say, uh, the server side applications, concepts of cache related to cloud and on-prem databases, and then I think we can also look at, in part three, some of the most commonly used caches, for example, Memcache and Redis, and see, I think, how they are used in the industry. But for now, I think, I hope this was useful, and we'll carry on this conversation in part two. Thank you so much.